Welcome to the DIY Honda Garage channel. DTC B1241 refers to an issue in the front blower motor circuit of the 2011 to 2017 Honda Odyssey. The blower motor is responsible for moving air through the vehicle's HVAC, heating, ventilation, and air conditioning system, ensuring the comfort of passengers by regulating temperature and airflow. Located typically behind the dashboard, the blower motor is connected to various circuits, including the power transistor and associated fuses, which help control its operations. When a fault occurs, such as an open circuit, short circuit, or a blown fuse, the system triggers DTC B1241, indicating a problem that requires further diagnostics. Proper functioning of the blower motor is crucial, especially in varying weather conditions, as it affects both heating and cooling efficiency. Therefore, addressing this code quickly can lead to a more reliable and comfortable driving experience. The components affected by DTC B1241 include the front blower motor, the power transistor, and several fuses associated with the power supply. The front blower motor's role is to circulate air through the cabin, facilitating temperature control and comfort for all passengers. This motor operates in conjunction with a power transistor, which regulates the speed of the blower motor by modulating the voltage. In terms of location, the front blower motor is typically found beneath the dashboard on the passenger side, while the power transistor and relevant fuses are located in the main under-hood fuse box and the driver's under-dash fuse relay box. Understanding the locations and roles of these components is critical for effectively diagnosing and addressing the DTC B1241 error code and restoring proper function to the vehicle's HVAC system. The potential causes for DTC B1241 include blown fuses, short circuits in the wiring, and loose connections within the blower motor circuit. Blown fuses, such as the number A38 40A fuse or number C26 7.5A fuse, can disrupt the power supply to the blower motor, causing it to fail. A short circuit may occur due to frayed or damaged wiring, creating unintended paths for electric current that can overload the system. Loose connections, especially at the blower motor or the power transistor, can also prevent the proper flow of electricity, leading to non-functional blower operations. Each of these issues needs to be thoroughly investigated to properly diagnose the root of the DTC B1241 error. Early identification of these causes can prevent further damage and ensure the longevity of the vehicle's HVAC system. Symptoms that may indicate DTC B1241 include an inoperative blower motor, illuminated DTC indicator on the dashboard, and potentially unusual noises originating from the blower motor area. An inoperative blower motor means that air is not circulating through the HVAC system, leading to undesirable environmental conditions inside the vehicle. The DTC indicator serves as a warning to the driver that there is a fault present in the HVAC system that needs to be addressed. Additionally, if the blower motor is failing, drivers might hear strange noises like rattling or grinding, which can suggest that the motor's internal components are damaged or obstructed. Recognizing these symptoms promptly can assist in timely troubleshooting, enhancing comfort and safety for the passengers. The first troubleshooting step for DTC B1241 involves clearing the diagnostic trouble codes, DTCs, using Honda's HDS, Honda Diagnostic System. Clearing DTCs resets the system and allows technicians to verify if the error is persistent or intermittent. After clearing, the ignition switch should be turned to the lock position and then back to on position without starting the engine. This action empowers the vehicle's system to refresh and prepare for the self-diagnostic test. Subsequently, performing a self-diagnostic function using the HDS or HVAC control unit enables detection of any current DTCs present. This step is crucial in determining whether DTC B1241 returns, indicating a consistent issue that requires further inspection, or if it was a fleeting glitch in the system. In the second troubleshooting step, you will check for diagnostic trouble codes once again after conducting the self-diagnostic function. The primary goal is to verify whether DTC B1241 is indicated. If DTC B1241 appears, it indicates that a consistent issue persists within the blower motor circuit that requires further investigation. Conversely, if DTC B1241 does not appear, this suggests that the problem may be intermittent. In the case of an intermittent failure, technicians should check for loose wires or poor connections in the front blower motor circuit to see if any components might have temporarily disrupted connectivity. By methodically checking these connections, one can often identify and rectify the cause of the intermittent failure, restoring proper functionality to the blower motor. Step 3 involves turning the ignition switch to the lock position to ensure safety before performing any inspections. The next task is to check the designated fuses related to the front blower motor circuit. Specifically, you need to inspect the number A38 front blower, 40-amp fuse located in the main underhood fuse box, and the number C26 7.5A fuse located in the driver's under-dash fuse relay box. These fuses play a crucial role in ensuring that the blower motor receives the correct power supply. If either of these fuses is blown, it indicates a disruption in the electrical circuit that powers the blower motor. Therefore, proper assessment of these fuses is essential in determining the next steps toward rectifying DTC B1241. After checking the fuses, you'll need to evaluate their status. If the fuses are intact, you may proceed to the next troubleshooting step. However, if any fuses are blown, they should be replaced promptly. This is essential, as blown fuses indicate a larger problem within the circuit that could pose continued issues. After replacing the fuses, it is crucial to recheck to confirm whether the new fuses operate correctly. If the replacement fuses blow again, this indicates the possibility of a short in the number A3-8 or number C26 fuse circuits. A short circuit occurs when the electrical current finds an unintended path, which can lead to overheating or damage to components. Therefore, identifying and resolving short circuits is critical to restoring proper function to the blower motor circuit. In the fifth troubleshooting step, you will connect terminal number 1 of the front blower motor 2P connector to body ground using a jumper wire. This process allows you to directly test the motor's functionality by providing an alternative path for electrical current, essentially bypassing the normal control signals from the power transistor. After connecting the jumper wire, turn the ignition switch to the on position. If the front blower motor runs at high speed, it indicates that the motor itself is operational. This step is crucial in determining whether the issue lies within the blower motor or if there are problems elsewhere in the circuit. If the motor does not run under these conditions, further investigation of the blower motor or related components will be necessary. After verifying the operation of the blower motor, turn the ignition switch to the lock position to ensure the vehicle's systems are powered down before handling any electrical connections. Next, disconnect the jumper wire to return the circuit to its normal state. Following this, it's essential to disconnect the front power transistor 5P connector. The power transistor is crucial as it regulates the speed and functioning of the blower motor based on signals from the climate control system. Troubleshooting continues with this step as it helps isolate the issue, determining whether the problem lies with the motor, the power transistor, or the surrounding connections and circuits. The final troubleshooting step involves checking for continuity between terminal number 4 of the front power transistor 5P connector and body ground. This continuity test is crucial to ensure that the power transistor is indeed receiving the necessary grounding. A lack of continuity indicates a problem within the circuit, such as a broken wire, corrosion, or a loose connection that could be preventing proper communication between the power transistor and ground. Ensuring a reliable ground connection is essential for the proper operation of many vehicles' electronic systems. If continuity is present, it suggests the power transistor may be functioning correctly, indicating that the next step would be to examine the blower motor or the entire HVAC circuit more closely for further issues. In the final repair verification phase, it's crucial to confirm that the blower motor operates properly after performing all necessary checks and repairs. This includes ensuring that the blower motor runs effectively at all speed settings and responds correctly to adjustments made via the climate control system. After repairs, it's essential to monitor whether DTC B1241 or any other related codes return. Ideally, if all previous issues have been addressed adequately, you should not see a recurrence of this code. Finally, conducting a thorough test of the entire HVAC system ensures that all components work in harmony, providing optimized performance and reliable operation for the vehicle's comfort features. Conducting this final verification solidifies that the repairs made are effective, ultimately enhancing the driving experience. Preventive maintenance is essential in prolonging the lifespan of the blower motor and the entire HVAC system in your Honda Odyssey. Regular inspections of the fuses, particularly the number A3840A and number C26 7.5A fuses, can help prevent failure due to electrical overload. Checking for loose connections or worn wiring periodically can greatly reduce the risk of intermittent faults or short circuits. Ensuring that the blower motor operates efficiently and inspecting the surrounding area for any obstructions can prevent unnecessary strain on the motor. Incorporating these preventive measures into regular vehicle maintenance schedules will contribute to improved reliability and performance of the HVAC system, minimizing costly repairs and downtime in the future. In conclusion, troubleshooting DTC B1241 entails a systematic examination of the blower motor circuit within the Honda Odyssey, initiating with clearing DTCs. Thorough inspections of fuses, wiring, and connections guide technicians toward identifying the root cause of the issue. Addressing blown fuses and potential shorts, as well as confirming the functionality of the blower motor and associated components, are vital in resolving the error. Finally, regular preventive maintenance practices will ensure that the HVAC system remains operational and efficient, minimizing unexpected failures in the future. Comprehensive understanding and following these steps will not only aid in resolving DTC B1241, but also contribute to the overall longevity and performance of the vehicle. Please like and subscribe to the channel. See you next time.